Welcome to another tutorial in ANSYS Workbench. In this tutorial, we are going to look at the stresses that develop in a bolted joint. The system consists of a cantilevered beam that is bolted to a vertical post with four 16mm diameter bolts. An end load will be placed at the free end of the cantilever beam. We will apply a preload to the bolts. The objective of this model is to investigate the possible modes of failure in the bolted joint. I hope you enjoy the tutorial. After opening ANSYS Workbench, I'll drag and drop a static structural into the project schematic window. Then I'll double-click on Geometry to open Space Claim. I will be using metric units in millimeters in this tutorial, so I don't need to change the units. The first thing I will do is change the sketch plane by right-clicking, then click Select New Sketch Plane, hover over the XY plane and click on it, then click Plan View. Now I'll draw the cantilever beam. To do that, I'll come up to the Rectangle tool and I will come over to the origin, click on it, and I will drag this out and I will type in 550 for the length, tab 200. And I now have the cantilever beam drawn, and I can go about drawing the circular holes. So I'll click on the Circle Create tool. I'll use my middle mouse button to scroll in, and I'll use these XY coordinates down here to hover over the coordinates of where I want to put my first hole, and that will be at a -40 and a 50. So coming in here and scrolling in, I can see that my X coordinate is at my 50 and I am at -40, and that will be the center of my first circle. So I'll click that and draw my circle, and these are 16mm diameter circles. So I'll type in 16, enter. I can now scroll back out using my middle mouse button, and I can click Escape to get out of the Circle tool, and I click Escape twice. Now I can come up to the Move, select this circle, and holding down the Control button, I can move it in the vertical direction, which will copy the circle, and I move it down 120 millimeters. I can now click on the top circle by Control-click, and I have both these circles selected. My move cursor moves to the center of those two, and I can click on the Control button and hold it down, and then click the horizontal move and move this 150 millimeters. I now have my four holes drawn in my cantilever beam, and I'm ready to move this and extrude this beam. So I will Control middle mouse button and move it more to the center. I'll roll out with my middle mouse roller. I'll click and rotate it. Now I'll come up and click on the Pull tool, and I'll pull this in the negative direction 15 millimeters. So type in 15, enter. I'm now ready to draw the vertical beam. So to do that, I come back up to the Sketch tool, and my sketch plane is this front plane, so I click on that. Now I can click on Plan View to orient it. I can come to the Rectangle tool and click on that, and I will offset this 20 millimeters. So from the top of the beam, I can come up 20 millimeters, and that will be my corner. And then I can extend my rectangle out, and it will go out 250, and then it will be 300 deep. I now have that rectangle drawn, and I can come and rotate this and pull it out, coming to the Pull tool and pull it in the other direction. And actually, when I do this, I need to select all three surfaces. So I'll click this surface, Control-click, and Control-click. And then I will come over here and click on the Add so that the area is added. Otherwise, this middle will not be shown. So I'll click on that and I'll pull that out 10 millimeters, enter. You can see now that I have surface and one solid, so when I did that pull, these two surfaces or these two solids became one. So I need to split those. To split those, I will click on the plane tool and generate a plane. The plane right now is on that front axis, so I need to take and move that plane. So I'll click move and I'll move that plane back 10 millimeters. Now I can come up to the split body tool and click on it, and I'll click the one solid. Then I'll come over and highlight the plane. I need to make sure I get the plane and not some other plane. The plane I just created, I'll highlight that and click that, and I can now see that I have two solids over here, a plane and a surface. I can go ahead and click on surface, right click on surface and click delete, and right click on plane and click delete, and I now have two bodies. I can click on the solid and see that it's gone, and then I can see the other solid one. To undo that command, I can click the undo and see my two bodies. They have the 16 millimeter diameter holes in them, so I'm ready to draw my bolts. To draw the bolts, I'll come back to the sketch plane and I will click on this front plane, and I need to make sure that I realize where I am, and I'm on the interface of these two planes, so I'm going to move this sketch grid out 10 millimeters. Now I can orient and look at my plan view, and I can generate a 16 millimeter diameter bolt. To do that, I'll click on the circle tool, I'll scroll in, and I will pick the center point there and draw that 16 millimeters. I can now rotate this and pull this 25 millimeters to go through the length of the two members. So I'll click on the pull tool, come to this face and extend it out 25 millimeters. I'll now come back to the sketch tool and click on this front plane, and I will right click and move the grid, and I'll move the grid out the height of the bolt head, which is 10.75 millimeters. So 10.75 millimeters, enter. And now I can come back and look at this in the plan view and click on my circle tool again, come to the same center that I used to create the bolt shaft, and draw a 24 millimeter diameter circle. Now I can rotate this and come to the pull tool, click on pull, and I'll click on this face, click the up to button, and then click on the top face of the bolt shaft. And that creates my bolt. To generate the nut, I'll rotate my my structure so that I'm looking at it from behind. I will click on the grid, the sketch grid, and I will move this sketch grid out to the back side of the plates. So I will need to right click and click on move grid. Now I'll need to move this the 25 millimeters to get through the two members, plus the 14.8 millimeters, which is the thickness of the nut. That will be a total of 39.8 millimeters. So I'll click on this and move this sketch grid out a distance of 39.8 millimeters. Click enter. I can look at it from the back, so I'll rotate this around and click on the negative Z direction. I'll come to my circle tool and I'll use the same center. The nut diameter is the same diameter as the bolt head, which is 24 millimeters. I'll now create another 16 millimeter diameter so that I can keep the bolt going through the nut as a separate body. So I'll click on the center again, pull out, and type in 16. Now I can middle mouse button and rotate this, and I will click on the pull tool and pull this interface up to the base of the existing bolt shaft by using the up to tool. Then I'll click on that face, and now I have extended my bolt out through my nut. Now I'll take and click on the nut and pull it a distance of 14.8 millimeters. And I need to be careful with that because now that has merged. I want to make sure that I undo that, and not when I do that pull, I want to make sure I have on no merge in my options under pull. So I now have on the no merge. I can grab this and I can pull this up 14.8, enter, and now I have kept my nut separate from my bolt. I can go ahead and reorient this so that I'm looking at it in the Z direction, and I can come to my bolt and copy that. So I can click over here and then control click this as my nut, and I can come to my move tool and hold down the control button and move that and copy it, and I will do that 2 more times. I now have all of my bolts and nuts created, and I'm ready to move them. To move the bolts, I'll click off my structure, and then I will roll out and middle mouse button and rotate it a little bit. Then I will come up to the assembly along the top menu and click on assembly. Then I'll click align. I'll come down here and hover over the bolt till I get the middle line, the center line, and I'll click the center line, and then I will come over and find the center line of the hole and click that center line, and that will move the first bolt. I can now come to my second bolt and again hover over the center line, come up to my structure, my plate, and hover over the center line and move my second bolt. And I will do that again for the third bolt. So I'll hover over the center line, find the center line in the hole and hover over it. Then my last bolt, hover over the center line, click it, and then hover over the center line and left click. And I have now moved all of my bolts. The bolts were developed so that the face, the head of the bolt, will lie right underneath right on top of the plate as it should be. Now I'll go ahead and move my nuts. So to do that, I'll use the same align tool where I click on the center of the nut, and then I'll come and find the center of the bolt and click that line, and it will move my nut. So again, I click on the center line of the nut and come up and click the center line of the bolt, and I picked the wrong center line there, so I need to redo that one. I'll click the center line and then come up and click the center line and move that. Then I'll click the center line again, move my next nut, and then finally I can move my last nut. And I have created my geometry. I can see that I have all of these solid bodies. I could rename those, which might be helpful, but I'll go ahead and just do that in ANSYS Mechanical, so I can orient my structure to look at it in the Z direction, and I'm ready to move to ANSYS. After opening Mechanical, we can see our beam and our plate and our bolts have been brought in. If I click over on the structure tree under geometry, I can open the geometry and I can click through and see the various components of my model. I'm going to rename these because the names will be useful in later analysis. So the top one I will click on and then click F2 on the keyboard and type in beam. The next one I'll click on F2 on the keyboard and type in plate. Then bolt 1. Now when I click on this one I don't see it, but if I wrap behind and rotate my model I can see that it's that nut on the bottom, and so I will actually call that number 4, and I'll call that F2 nut 4, and then F2 bolt 4. Now I need to rotate this around, and this will be nut 1, so F2 nut 1. Then this will be F2, click on it, F2 bolt 2. F2 nut 3. F2 bolt 3, and finally nut 2. F2 nut 2. Now I have all of those components named, and I'm ready to move on. So I'll minimize the geometry window, and I'll come down to connections. And connections is where ANSYS puts the bodies in contact that it thinks should be in contact with each other. So if I open up the contacts, I have a whole bunch of contact regions here, and these have been automatically generated by ANSYS, and I need to go through and check those. So to do that, I click on my first contact region, and what it shows me is it shows me this red face, and then on the back side over here it shows me this blue face, and those two faces are the contact for the red face and the target body for the blue face, and it's telling me that those two faces are in contact. It's also telling me that they are in contact with a bonded type of contact. And these two members are certainly not bonded. Bonded means they're essentially welded together and hard connected, where these would be more of a frictional contact. So I need to click on this window, open it up, and click frictional. And I can see now when I do that, it comes back and uses the names that I gave it in my geometry description, and it says I have the beam to plate contact, and it's a frictional. It's also asking me for a friction coefficient, so for a steel on steel, I'll use a 0.2, enter. Now since most of my contacts are going to be frictional contacts, I'm going to select the next one, shift click the bottom, then change all of them to frictional with a friction coefficient of 0.2. Enter. And now I can see that it has named all of these based on the names I gave it in geometry. And the only ones I need to come and change are the nuts to the bolt, where that will be a bonded connection. So I'll come to nut 3 to bolt 3, and I will change this down here from frictional back to bonded. And then bolt 2 to nut 2, I'll change that back to bonded. Nut 4 to bolt 4, back to bonded. And bolt 1 to nut 1, back to bonded. The other thing I need to do is go through all of these and ensure that all of my connections have been made. If I need to add any, I come to contacts and right click on contacts, click on create, and I can create a contact tool, or I can come to insert manual contact region and enter in a new contact. But ANSYS did a good job here, and it got all of the contacts that I needed. I'm now ready to move. To mesh the structure, I'll begin by clicking on mesh, then come up and generate the default mesh and see what it looks like. This mesh is too coarse, and so I'm going to want to refine it. The first thing I will do is come down and refine the mesh by increasing the resolution here to a resolution of 3. So 3, enter. My mesh goes obsolete, and I can click update. This mesh is beginning to look a little bit better, but I'm going to enter in some more specific controls. So under meshing, I will come to refinement, and I'm going to refine the mesh around these holes. And so I will come over and up to the geometry and click on my first bolt and right click and click hide body, and then bolt 4 I'll right click and hide body, bolt 2 right click and hide body, and bolt 3 right click and hide body. Now I can see inside of those holes and I can select those faces for mesh refinement. So I'll come back down to this refinement and I'll click on the surface select. I'll need to control and move and middle mouse button rotate so that I can see those surfaces. I'll click the first one, then control click, and I should get the hole in the plate and the hole in the beam. So I'll have a total of 8 surfaces. Then I'll come over here and click apply, and I'll increase this refinement to 2, enter. And now I can see my mesh went obsolete again. I can click update. So I can see my mesh looks a lot better now around the holes. The mesh is in the 2 plates, or the plate and the beam. Now I'll refine using a face sizing. So I'll come up to sizing and click on sizing. Then I'll click the faces of my plate and my beam. So click to select that face, control click. Now spin it around and control click these other 2, and I can click apply, and the default size here I will put in as 0.01, enter. Now I can update this mesh, and that mesh looks pretty good. The mesh refinement around the holes looks great. One thing that you want to note is that it's never good to just have an element on the, or a node on the surface and on the back surface. You need to have a node on the middle line, or some type of a breakup at least going through the thickness of the members. So I'm going to go ahead and enter in another sizing, and I'll click on all these edges. So click the first one, then control click, and then I'll rotate it around and make sure that I get all of the edges. Again, I should have 8 of them. And I can look at my mesh again, and I'll increase this, or set the element size here to a 0.005. And now I'll do one more mesh update and see what that mesh looks like. You can see the progress of the meshing down here. So I now have elements going through the thickness of my members. I have good refinement around my holes. So that all looks good. I can right click and then click show all bodies, and my nuts and bolts are back. I don't need a lot of refinement on my nuts and bolts, as I'm not too concerned about the deformation or the stresses in the nuts and bolts. I'm more concerned about the stresses in the beam and the plate. So my meshing is complete. I'm ready now to go in, enter in my static structural boundary conditions. To do that, the boundary conditions that I will use, I'll use a fixed boundary condition down on this bottom face of the plate. So I'll come up to fixed, be on the surface select that bottom face, click apply, and then I'll apply a load eventually out here on this face, but I'm going to look at the pretension in the bolts first of all. And so to do that, I'm going to hide the beam and the plate. So I'll come over and right click on beam, click hide body, right click on plate, click hide body, and now I just have my bolts. I can come up to static structural, I can come to support to loads and click on bolt pretension. Then I can zoom in and I can click that surface of that bolt, come over here and click apply. and I will apply a preload of 2000. And it doesn't look like I got it selected up here, so I'll click apply again and I can see that I get the one face. You can't select all four faces at the same time, you have to do them individually. So I'll click on this face again, come up to loads, enter in another bolt pretension, click apply, and enter 2000 newtons. And I will do that 2 more times. And 1 more time. Click on the surface of the bolt, click on loads, bolt pretension, click on apply, click on 2000, enter. I now have the pretension applied in all 4 bolts. I can come and define the outputs, so I'll click on solution, I'll look at stress, equivalent von Mises, I'll look at deformation and total deformation. I'm now ready to go ahead and solve this model, and I'll look at just the effects of the preload. This will take a while to solve, so while it's solving, once a solution has been obtained, I want to come over to the window and right click and click show all bodies. Then I can come and click on equivalent stress, and I can zoom in and look at the stresses around the bolt. I can see that it looks like this bolt has compressed that material and has been sucked down in. I can see on the back side that my nuts have been compressed down in, and so all of that looks good. It looks like what a press fit should look like. I can come up to bolt 3 and right click on bolt 3 and click hide body. Then I can click on equivalent stress again, and I can more clearly see the stresses in the hole and around the hole without the bolt being in the way. And again, I can look through there and see that that looks like what I would expect a preload to do. So my preload looks okay. I'm going to go ahead and middle mouse scroll this out, click on ISO, and now I'm going to come back to static structural and add a force to the end of this cantilever beam. So I'll click on it, I'll click apply, and I'll change from vector to components, and I'll apply a Z component or a Y component, a minus Y of 1000. Now I'll go ahead and click enter, and I'll resolve this with a 1,000-pound load. After the solution has been obtained, we can investigate the various modes of failure in the bolted joint. If I turn to look at the structure straight on, I can see that the largest equivalent stresses occur in this region and then over here in this region. If I come up here to bolt 3 and right click and hide body, and then click on bolt 4, right click and hide body, I can look at the plate and the beam a little more carefully. So now I'll rotate it and then click on equivalent stress, and by zooming in I can see that there is a higher stress right here in this region, and it looks like there is some bearing failure on the plate, or that's where the stresses would be the largest, is in that direction, pulling out like that. I can come over here to bolt number 4, and I can also see that there's some bearing stress down in here. In terms of shear tear out, that doesn't look like that will be a mode of failure, or the other failure modes don't look to be a significant concern on this front plate. If I rotate the plate around and look at the back side, I can see here that likely this would be a tensile tear out on this top member here. This will be a compressive stress down here. I could hide these nuts and look at the nuts and do more investigation, but likely we would have a tensile tear out in this region as the failure mode. So hopefully this has given you an idea of how to use finite element analysis to investigate possible modes of failure in bolted joints. I hope you've enjoyed the tutorial.